This is an overview of the MSc Environmental and Engineering Geoscience, which is a new program launched by our school, and the application code is F290. This picture in front of you is taken at the Dead Sea by myself. It's showing some collapsed sinkholes. Can you see my cursor? Some collapsed sinkholes here. You've got some people for scale, and you can see some destruction of roadways and houses and buildings. And I wanted to show you this just to give you a flavor of some of the types of challenges that we have in environmental engineering geoscience. So the Dead Sea is a lake, and it's been fed by a river Jordan, which has been blocked for irrigation purposes for several decades now. And as a consequence, the Dead Sea is sort of dying and drying up. And this is essentially a classic man-made geo-environmental problem. Because the lake level is going down, and as it goes down, it's causing the formation of thousands and thousands of sinkholes. And there has been a proposed engineering solution to this, which is to link the Red Sea, which is just south of the Dead Sea, through to via canal. And this would then bring back the water level and stabilize the entire environmental system. However, this doesn't reckon with some major geological issues, which is that this canal has to go across a major tectonic fault structure. And when you consider that there's going to be $11 billion spent in this, that's quite a big, risky project, which geoscientists can probably advise very closely on. Closer to home, we have environmental or geoscientific environmental problems with, for example, coastal erosion, not least here in our neighbourhood in Dublin. Again, there are major, costly geoengineering solutions that are being proposed to deal with these. So, what sort of insights can geoscientists bring into this area that maybe engineers and others working in construction don't necessarily have themselves? Final example here is one of landslides in Ireland. This is a peat landslide that impacted an area in Leitrim. And you can see that there was a bridge. This landslide started at the top of the hill here, went down and hit a bridge. And the cost, there's the bridge destroyed by the landslide. And the cost of reconstruction is estimated at several million euros. So these are major societal problems that geoscientists have, can bring major insights into. This is data from a recent 2025 survey of 135 geotechnical contractors, consultants, and suppliers that operate in the UK, which is a similar market to here in Ireland. And their number one concern going forward is that they have a shortage of skills in the area of ground engineering and geotechnics. And this is the fourth year in a row that they've reported this as the number one concern in the industry at the moment. So, with this in mind, we have proposed this new master's program. And I'll run through now quickly the course structure as we have it currently. So normally we will the teaching goes over 1 year. It's broken up to 3 trimesters. The first trimester is in autumn, and these are showing the core modules that you will take in the autumn semester. So the ones in green here are taught by the UCD School of Earth Sciences. The ones in blue are taught by our colleagues in the civil engineering department. In addition to having these core modules, which are mandatory, we'll give some optional modules, one choice of an optional module. These range, as you can see here, for some modules taught by our own department, and also some optional modules that are being taught by colleagues in geography and in the School of Biology and Environmental Sciences. In the spring trimester, this is what the program looks like, taking you through things like rock engineering, applied quaternary geology, hydrogeochemistry, remote sensing, and so on. And then again, you'll have these core modules followed by one choice of an option, either from ourselves in School of Earth Sciences or from our colleagues here in the School of Biology and Environmental Sciences. And then lastly, the final trimester will comprise an industry-linked research project, which will take you up to the end of the year, and hopefully with your masters you can then go on and look to have a career in various areas that are relevant, for example, to multiple United Nations sustainability goals, as shown here on this diagram, which is also available on our school website. In terms of student profile, we're generally needing you to have a bachelor's degree, ideally in earth sciences or geosciences, but also possibly several cognate areas such as environmental science, physical geography, and potentially even some of the engineering disciplines. And we'll also take into consideration if you've got significant or relevant work experience. In terms of career opportunities, we've identified talking to several companies and agencies that would represent prospective employers in Ireland and potentially abroad. We're seeing opportunities in ground investigation and geotechnics, slope stability assessment, groundwater research, resource management, construction site management, mine or contaminated land reclamation, land use planning, environmental rehabilitation, and impact assessment. So with that, I'll hand over to Tom, who will take you through our second master's and also tell you about what life is like as a student in UCD.
My name's Tom Manzocchi. I'm the manager of, or the director of the MSc in Subsurface Geomodelling, which is the second of these master programs that we have in the School of Earth Sciences. The logic behind this course really is shown by these two graphs, which compare on the left global energy use between a few years ago and 2050, and on the right, the total mineral demands for this energy change between now and 20 years from now. So obviously, we're going through an energy transition, we're going through a climate emergency, and associated with this energy transition is this shift from a fossil fuel dominated global energy system, which we have now and have had for the last 80, 90 years, into one dominated by renewables. That shift from fossil fuels to renewables can only really be accommodated by a massive increase in the mineral demands that we have to make those renewable systems work. So there's two real challenges here. One of them is providing the minerals that we need to help us make this energy transition. And the second demand here is that if we're left, as we are in this projected scenario, with about 25% of our energy system still dominated by fossil fuels and nuclear, then we need to dispose of the waste products associated with those energies. So these are really the challenges that we face, or some of the challenges geoscientists face going forwards. So the MSc in Subsurface Geomodelling really is aiming to tackle these challenges. So what we're really trying to do is provide a training in how we characterize and model the subsurface so that we can manage natural resources and storage space in the subsurface. So how do we use the subsurface to help us with our societal aims going forwards? So this diagram on the right there is very much showing both the shallow and the deep subsurface. And whilst the MSc that Eoghan's been describing, the Environmental and Engineering Geoscience MSc, is very much shallow, focused on the shallow subsurface, depths of maybe a surface processes and down to 100 or a couple of 100 meters. In the Subsurface Geomodelling MSc, we're really trying to focus on both the shallow and the deep. We probably have more of an emphasis on the deep than the shallow, but some of the methods and some of the modelling tools are common across all of these disciplines. So there's quite a wide range of employment sectors that we intend our graduates to go into, and in fact have seen our graduates go into. And we have a pretty good record of graduates finding good relevant geoscience jobs across a range of industries, but also in national geological surveys and regulatory organizations. So this is what we're trying to do really in the Subsurface Geomodelling MSc. Eoghan briefly described the structure of the course, of our MScs in general, 90 credits, of which 60 are taught modules in the first two trimesters. And really in our course, we can split those into four kind of groups. First of all, we're concerned with how we characterize and describe the subsurface, which is really looking at geological aspects, thinking about how we describe those from a quantitative perspective. Data acquisition is a very important part here. Javier there is flying a drone, but of course, we drill wells, we shoot seismic. There are many ways of acquiring and understanding data. And then finally, in the modern environment, we bring those data into workstations, have sophisticated software packages in which we make predictions about the subsurface, which help us with our applied ventures, I suppose. So in the remainder of this talk, I suppose, I'm going to describe a little bit about how we work, how our MScs work in the School of Earth Sciences, which is a home to both the MScs we're describing today. I've got more of a focus in these slides in the Subsurface Geomodelling rather than the Environmental Engineering Geoscience MSc, because we've had it going for a bit longer. but the general kind of way we work is similar for both. You'll see from this photograph, we're a relatively small school within UCD. However, we are the largest earth sciences school in Ireland, and many of our academic staff are contributing to both these MScs. So, we also have dedicated IT support, of course, within the school, which is very, very important for our subsurface geomodelling. These 1-year full-time courses. So they kick off next year. This year they will kick off on the 7th of September and finish up sometime in mid-August. So we have these initial 2 trimesters which are teaching trimesters. So we do 30 modules in each of these 3 trimesters. The first 2 are teaching and fieldwork trimesters, and the third one is dedicated to an independent research project by each student. This is an example of what our current timetable actually for the Subsurface Geomodelling MSc looks like in the spring. So we start late January, finish up in late April, and the different colors there are the different modules. So you can get a sense of, some of these modules, like this green one I'm pointing out here, are quite focused modules on a particular aspect. That's a team building module or a teamwork module. Some of them are more dispersed across the trimester. These big orange blobs are fieldwork modules, and of course we always try and timetable in a bit of downtime as well. But it is a full-time MSc course over these 3 trimesters over the year. How do we teach? We've got probably about 25% of our timetable time is dedicated to lectures. Another 35% perhaps will be dedicated to, in the case of the subsurface characterization MSc anyway, is dedicated to practical work. And a lot of that practical work is associated with software. So we use the sort of industry standard, high-end market leading software, for example, Leapfrog and Petrel, used by the minerals and the subsurface industries. But increasingly, people are interested, and the range of softwares available as sort of freeware is increasing. So we are very much using Python-based codes and giving Python-based training so that we can exploit these or use these more, these open source, more kind of more readily available softwares in addition to these kind of leading industry software. So we're trying to cover the spectrum really of the experience and the training we provide on the practical side of the course. As I said, a lot of a lot of what we do is teamwork, and that's an important part of the training and presenting the results of teamwork. We're in the lab quite a lot, but we also get out, and it's important to get out into the field and drill sites and petrophysics labs and core stores to really get a sense of the whole process of acquiring data and working with data. Field work's quite important. We've got 2 main field trips on our MSc. One of them is looking at the Irish ore fields. And the final field trip we run on the module is in the Spanish Pyrenees, really trying to understand large-scale structure and sedimentological trends there and how they're incorporated in subsurface modeling workflows. We've got good links with industry, and this is certainly true of both the MScs. We've got very good links with industries in Ireland, and we often get in industry staff to kind of help out with teaching or assessment of work, and it's fantastic for the students to have these contacts with industry professionals. Sometimes this can lead to networking opportunities that lead to jobs or whatever, but it's good to have this wide, this wide exposure to varied communities. Ireland's a relatively small country, and the geoscience community in Ireland is pretty small and close-knit. So there is generally really good integration between academia and the government organizations such as the Geological Survey and industry as well, and that's important. And the final 3 months of the project then are the independent research projects. And that's where you really get the opportunity to put your learning into practice for a particular topic. I'm not going to go into details about those, but it's an important part of the work. So finally, as the MScs have fees associated with them, and I've just listed the two fee levels there for the EU and non-EU students. There are various scholarship and stipend opportunities, and they're definitely best kind of explored in the context of the various websites. But here I'm just highlighting three of these opportunities. You know, the first two there are provided by UCD Global, who, you know, there's an opportunity to apply for significant tuition fee scholarships. However, the deadlines vary by geographical region, but one of the significant deadlines for applying for those, I think, is the end of this month. So there's only a few days left to meet that deadline. Another important deadline for our courses is the International Student Scholarship. So depending on the level of your qualifications when you apply for the course, you are automatically assessed and you may be offered a significant scholarship off the tuition fees as part of your application process, which obviously would bring this down quite significantly. The other thing we're offering from the School of Earth Sciences rather than from UCD Global are these two families, if you like, of scholarships and stipend opportunities. One of them, the first of these, is applicable only to people paying the EU fee level, which is a fee waiver, so a 100% tuition fee scholarship for up to 2 EU applicants. And the other one is a contribution to living expenses up of the value of €20,000 for up to 2 non-EU applicants. So you can see details, as I say, on our website about how to apply for these scholarships. And there are other opportunities available. But I would make the point that these are competitive, and they're very competitive. So if you are looking to come and join our MSCs, we would very much encourage you and recommend that you do try and find scholarship opportunities that you can bring with you from perhaps your own governmental organizations in your own countries, because it is tough. It is tough to find to find the funding to put yourself through these MSc classes.